In this lesson, we're going to talk about how to solve simple algebraic equations. And by simple, I mean ones that involve multiplication and division. All right, so there's sort of three general steps for what we are trying to do here. And there's always something we want to solve for. So the thing we want to solve for is going to be represented by a letter. And frequently people use the letter X. There's absolutely no reason why it needs to be X, and we will do examples where it's not X. But a lot of times people say they solve for X. Okay, so the goal is to solve for X. And how we do that in an equation is that we get X by itself on one side of the equation, which means on one side of the equal sign. And the third thing is that anything we do to one side of the equation must be done to the other. Okay, and so the reason for that is that otherwise it wouldn't still be an equation. It wouldn't still be equal. Okay, so let's go to one very simple case. We'll start with a simple case of solving an equation. And we have an x in this equation. And this first case is where we have no denominator, or in other words, nothing on the bottom. We don't have any fractions. All right, so 2x equals 6. Very simple. The goal is to get x by itself. All right, right now x is being multiplied by 2. And we show multiplication in this way, just putting the 2 next to the x. But there are some other ways you can show it too. So multiplication can be shown as 2x, or 2 with a dot between it and the x, or you can use parentheses around each thing that is to be multiplied. Those are all used. Okay, so if we want to get x by itself, the first thing we need to do is divide both sides by x, since right now the x is, divide by 2, since the x is now multiplied by 2. So we're going to divide by 2 on both sides. Okay, so we'll write 2x equals 6, and we'll divide by 2 on the left and divide by 2 on the right. Then we can always cancel things that are on the top and the bottom of a fraction, so we'll cancel those 2's, which leaves x all by itself on the left. On the right, we have 6 divided by 2, so we have to simplify that, and that's 3. So we've now solved this problem for x. And obviously this was a very, very simple problem, but it shows the concept and the process. Now if you look at the equation in B, it looks way more complex, and our applications will usually be more complex looking. But if you boil it down to its simplest form, it's the same as 2x equals 6. If you look on the left, you have an x here, and that's what you want to solve for, and there's something multiplied by x. In this case, it's a more complex number, and it has units, but it's still the same form as in part A. On the right-hand side of the equation, you have 3 things multiplied by each other, each in parentheses. Each of these things have units and numbers, and they look complicated, but when put together, they're just going to be a number and a unit. All right, so the process is the same. So up in part A, to get x by itself, we had to divide both sides by the thing x was multiplied by. So the same thing here. We're going to divide both sides by 0.997 ATM. Which happens to be atmospheres, but you don't have to know that. All right, so we're going to take that equation, we're going to actually rewrite it. All right, 0.997 ATM times x equals, and then all this other stuff, 1.3 moles, 0.0821 liter atmospheres per mole Kelvin, and 273 Kelvin. Okay, now we're going to divide both sides by the thing that x is multiplied by. 0.997 ATM on the bottom of both sides. Okay, now let's start simplifying. On the left, you have the same thing on the top and the bottom, so again, that cancels. Both the number and the unit cancel because they're the same, which leaves x by itself on the left, exactly what you want. Now, the right is going to take a little more effort to simplify. Let's start with the units. Notice that one of the factors here has units that are on the top and the bottom. So, but the ones on the bottom, mole and Kelvin, are on the bottom of the top of the entire fraction, which really means that those units are effectively on the bottom of the entire fraction. So the bottom of the top is the bottom. So think of the mole and Kelvin as being down below. So I'm just going to actually rewrite them down there to make it easier to cancel. All right, so moles here cancels with moles below. Atmospheres up here cancels with atmospheres down there, and kelvins here cancels with kelvins again here. That leaves us, the only unit left is liters, so that's going to be the units of our answer, and I'll write that out first. Then we'll do the numbers, and in your calculator you will punch in 1.3 times 0.0821 times 273 divided by 0.997. Now when I do that, I get a long string of numbers, 2.922496489, and that's a long number, and if you think about the significant figures, you realize that's way too many digits. We don't know this number that accurately. So we will look at how many digits that comes from. There's 3 over here, 3 significant digits, 2, and 3, and 3, and 3. So everything's 3s and 2s. The smallest is 2. So your answer is going to be good to 2 digits. So the real answer that you would report is 2.9 liters. So that was case 1, where there's nothing on the bottom, at least to start with. Now let's try case 2, where there is something on the bottom. There's a denominator on at least one side of the equation already when you start. And let's say further that in this case the x is in that denominator. Alright, so the first step in this case is to make fractions on both sides of the equation. So we'll just copy over the left side, which is 16 over 4x, and the right side is a 2, but that's effectively on the top, that is on the top, and you can always put it over 1. You can put anything over 1, so we put it over 1 to make it fractions. Because once you have both of them as fractions, you can do something that's called cross-multiplying. But first I'm going to write in the instruction that you make both sides a fraction. And they may already be a fraction to start with. Alright, but let's do cross-multiplying. Alright, so what is cross-multiplying? It is taking the bottom of one side and multiplying it by the top of the other. Okay, so you end up with 4x times 2. And that will equal the other cross multiplication, the 16 times 1. Okay, so that's what you do. You take the cross parts and you set them, multiply them by each other, and then set them equal to the other cross part. Okay, and that's called cross multiplication. So I'll say cross multiply. All right, and then you simply solve. You now have an equation that looks like case 1, where everything is on, there's no denominators, everything's on one line. So you start solving. All right, so when you have 4x times 2, the 2 and the 4 get multiplied by each other. The numbers get multiplied. Okay, so let's show that in a margin over here. 4x times 2 is going to equal 4 times x times 2. And everything is commutative here, so you can move anything around, which means you can say it's 4 times 2 times x, and therefore you can say it's 8x. All right, so we will simplify this as 8x on the left, and 16 times 1 is 16. Now we divide both sides by 8. Okay, and so that will be 8x over 8 equals 16 over 8, which means on the left we get x, because the 8's cancel. On the right, 16 divided by 8 is 2. So that is your answer. Just like with case 1, that's a simple example. Let's do a slightly more complicated example. With units, it's not really mathematically any more complicated. It just looks more complicated. So here's an equation, already has fractions on both sides, so we don't have to put anything over 1. But if there was a fraction on only one side, we would put it the other side over 1. All right, so we're going to cross multiply. We're going to say that the things across from each other are multiplied. So 373 Kelvin times 631 torr is going to equal the other cross multiplication, 738 torr times x. All right, and you can put x on either side. It doesn't matter. People seem to like to have it on the left, but it can be on the right. It does not matter. Okay, so we're going to divide both sides by 738 torr, because that's what x is multiplied by, just like before. So instead of actually writing that over again, I'm going to just skip that and say x. But the other side, you have to remember to divide by 738 torr. So I'm going to do that. I'm going to rewrite it. And divide it by 738 torr. All right, now we have to simplify the left because we have x by itself. So we cancel the torrs on the top and the bottom. We know our answer will be in kelvins. Okay, so we can say that, rewrite x equals, and it's going to be something Kelvin, and then you just do the math part, 373 times 631 divided by 738. You get 318.92005, maybe other digits depending on your calculator, and that will simplify to 3 digits because we have 3 here, 3 here, 3 here, everything's 3, so your answer should have 3, and we would have to round up that 9, so it would be 319 Kelvin equals x. All right, and please do remember that the unknown number can be any letter. And now we're going to do some examples with letters other than x. In fact, I'm going to have you solve them first. The first one is this, try this. You're going to solve for V2, and that 2 is not a mathematical 2. It's not multiplied or anything by the V. It's just a designation that this is the second V as opposed to the first V. Okay, so the V2 is not a multiplication. All right, so why don't you try first to solve this. It's got 2 fractions. You're going to need cross multiplication. Please stop the video and try it and check your answer, and I will show you after you have restarted it. Okay, let's solve this. We're solving for V2, which incidentally is a volume, and so in the end we will hope that we'll have a check on our units to see if they are volume units. All right, so let's cross multiply. We'll do the bottom of the first one times the top of the other. It doesn't matter. You can do it in either order you want to. And I'll actually write this in blue just to show where it came from. 284 Kelvin times 1 ATMs times V2. And that's going to equal the other side, which is 4 ATM times 25.0 milliliters times 291K. All right, so we have our unknown, which is V2. It's not X this time, it's V2. And that's what we want to get by itself on this side of the equation. So we're going to divide both sides by 284 Kelvin and divide them by 1 ATM. So let's do that. I'll rewrite the right-hand side. and it's going to all be V2. And divide by the 284K from the left and the 1 ATM from the left as well. All right, let's start canceling units. ATM on the top and the bottom cancel. K on the top and bottom cancel. We're left with milliliters. So I can write my answer units first if I want to. So those are done. And then I do, in my calculator, 4 times 25 times 291 divided by 284 and divided by 1. And what I get if I use 3 sig figs, everything has 3 sig figs in that, so what I get is 102 milliliters for my answer for B2. All right, now there's another try this to give you more practice. This time we're solving for T1, which is going to be a temperature, so hopefully we have a temperature in our units when we're done. So stop the tape and try it yourself. All right, let's cross multiply. I'm not going to draw the cross multiplication again because I think you have seen that enough times. So I'm going to do the T1 times the stuff on the other side on the top. Equals the cross multiplication from the other side, 0.560 ATMs times 40 ml times 273 Kelvin. All right, let's try to get T1 by itself, which means dividing both sides by 1 ATM and 15 milliliters, keeping all our units and all of our sig figs. So I recopied the top. The bottom is going to be what's on the left. And let's start canceling units. ATMs cancel, milliliters cancel. I'm left with kelvins, which is a temperature. So I'll put that down. Do the math, multiply all the tops, divide by the one bottom, divide by the other bottom, and I think you'll find that it is 408 Kelvin is what our T1 will be.